All right, in this next section, we are going to take a look at using trigonometry to find area. Okay, we'll mostly focus on triangles, but then we can use that also to find areas of other figures. So the first thing we want to look at today is deriving a couple of formulas that we're going to look at. So we're going to start with what we know, right? The area of a triangle is 1/2 base times height. Now, just one quick thing about notation in this section. Usually we denote area with a capital A, but we're going to use a capital K here because in most of our triangles we use capital A as one of the angles. So we're going to use a capital K to denote the area. Okay, so we know the area of a triangle is 1/2 base times information about the angles and the sides, not necessarily the height. Okay, so what we want to think about here is the height, remember, would be if I were to draw a line from B straight down like that. Okay, that would be the height of this triangle. So, and also remember that would form a right angle here. So we need to find, if we're saying the area is 1/2 base times height. Well, the base, we could just say here, if this is the side opposite B, the base of this triangle would be side B. So we can say K is equal to 1/2 B, but then we still need to calculate the height. Okay, well, we also know that this would be side C, right? If this is the side opposite angle C, and then this side over here we could call side A because it's opposite angle A. Well, we've already kind of looked at this a little bit. If we want to find the height here, well, I know angle A and I know side C. What we can do is think about this right triangle that we created by dropping this height down. So, with respect to angle A, this would be the opposite side, and this would be the hypotenuse. So using basic right triangle trig, we can say the sine of angle A is equal to h over c. Sine of A equals h over c. And then we want to solve for h, right? We want to get h by itself. So I'm going to multiply this c over and get c times the sine of A is equal to h. And that's what we're going to put into this formula for the height. So we're going to say 1/2 times B times C times the sine of A. Now, this would work very, very similarly if we just turned the triangle a little bit and said that, well, this side was the base, and then we drew a height in here. Okay, we would get a very similar formula. Okay, and here on this next slide, I've got a list of these three possibilities. Now, if we look, I guess I should go back here. If we look at the information that we used, okay, we used sides C and B in this example and angle A. This would be a case where we are given side, angle, side. Right? Two sides and the angle in between them. This is how we would find the area of that triangle. Okay, so here are those three possibilities then. So it's just 1/2 times the two sides times the sine of the angle in between those two sides. Right? And these would be the three different possible ways you could write that. So let's go through an example with actual numbers. So let's say we want to find the area of this triangle. Right? So we've got this side's 36, this side's 29, this side's 62. So we know K is equal to 1/2 times the two sides. So the two sides we have are B and C. So 1/2 BC times the sine of the angle in between them. So that's going to be 1/2 times 36 times 29 times the sine of 62 degrees, and we can just plug that into the calculator. So 1/2 times, what was it, 36 and 29, 6 times 29 times the sine of 62. And again, remember, make sure you're in degree mode. So we get an area of about 460.9. And we weren't given units here, right, but so I'll just write units squared. Right. So that's how we would find the area of a triangle if we know two sides and the angle in between. All right. So let's look at the next possibility. If we are given two angles and a side, okay, that could either be two angles and a side not in between, or two angles and a side that is in between. Okay, so let's just assume that the information that we're given is angles A and C, and then we're given side A. Okay, so we're given these two angles and this side. Well, if we're given two angles, all we need to do is take 180 minus the other two to get this angle. Okay, so we can easily solve for angle B. Well, then we kind of want to think about, well, doing what we did in the last derivation. Right? We want to find the height and the base. Okay? Well, to do that, right, we can first find another side of this triangle. To do that, we can use law of sines. Right? So we could say that since I know all three angles, let's say we want to find side B. Well, we could say that sine of B over B is equal to, since I know both angle A and side A, I will use that. And now we want to solve for B, right? That's my unknown here. So I would multiply the B over and then multiply both sides by the reciprocal here. So we would end up with A times the sine of B over the sine of A is equal to B. Okay, so we're saying that this side here is equal to this. Okay, A sine of B over sine of A. All right, and we just use law of sines to find that, something we've already talked about. Well, now if we think about using the formula that we already derived, right, where we already talked about finding the height, right, well, we just took this formula here, we can take this formula, k equals 1/2 bc sine of A. So k equals 1/2 bc sine of A. Oops, actually that's not the right one because I said that we were given A. Right, so we actually want to use this one. Right? If we're given side A, we want to use so we know sides A and B now. So A, B, sine of C. There we go. So now we can just replace B in this formula with this. So we can say k equals 1/2 times A times A sine of B over sine of A times sine of C. And we can clean that up just a little bit. We can multiply this A to this A and say that'll be A squared sine of B sine of C over and then that 2 is in the denominator, so 2 sine of A. Okay, so essentially all we did here to get this formula was find another side of this triangle and then multiply that by the height, which we already found the height was this piece right here. Right? So again, just like the first derivation, we could very similarly prove these two as well. Right? So these are our formulas to find the area of an angle-angle side or angle-side-angle triangle. Right? So jot these down, and then we'll go through an example with numbers here. Right? So we want to find the area of a triangle where we know side A is 16 feet, angle B is 57 degrees, and angle C is 49. So first, we could very quickly find angle A. Right? So A is going to be 180 minus 49 minus 57, and what do we get for that? 74. Right? So now we can just plug numbers into the formula. Right? We can go back here and say, well, the side that I know is side A, so the form of the formula that I'll use is this first one. A squared times the sine of angle B, sine of angle C. So K equals, I guess I'll write out the formula first. A squared sine of B, sine of C over 2 sine of A. All right, so plug numbers in. We'll have 16 squared times the sine of 57 times the sine of 49 all over 2 times the sine of 74 degrees. And we can plug all of that into the calculator. I'm just going to do it on my calculator here instead of the one on the computer. Times sine of 49 divided by 2 sine of 74. So I got 84.3. And we were given units this time, so that would be square feet. I guess one thing I should mention, if you plug all of this into your calculator at once, remember to include parentheses around the denominator. Right? When you hit the division button, put parentheses around 2 times sine of 74, otherwise you're going to get an incorrect answer. Right? So that's an example of area if we're given 2 angles and a side. All right? The final one that we're going to look at here is if we're given all 3 sides. Right? If we're given all 3 sides, we can use what's called Heron's formula to find the area. The derivation for this formula is actually kind of cumbersome, so we're not going to go through that. I'm just going to give you this formula to find the area of a side-side-side triangle. Now, in this formula, S shows up a bunch of times. S is called the semi-perimeter. It's just half of the perimeter of the triangle. Okay, so we want to take all 3 sides, add them together, and then just take half of that to get our value of S for this formula. Right? So let's go through an example here. So let's just say we've got a triangle with sides of 29, 25, and 40. So to use our formula, the first thing we need is S, the semi-perimeter. So that's just 1/2 times the perimeter, which would be all three sides added together. So what do we get for that? 47. So the whole perimeter is 94, and half of that is 47. So now, in our area formula, the square root of s times s minus a times s minus b times s minus c. We just plug our values in here. So the square root of 47 times 47 minus 29 times 47 minus 25 times 47 minus 40. All right, and we can just plug all of that into the calculator. And again, I'm just going to do it on my calculator here, save a little bit of time. And I think if we round to the nearest tenth, that comes out to about 360.9, and we are given units, so square inches. All right. So 3 different situations for finding area of an oblique triangle. Okay? The first situation, side angle side. If we're given 2 sides and the angle that is in between them, we can use one of these formulas. If we are given 2 angles and a side, whether that's 2 angles and an included side or 2 angles and a side not included, we can use these formulas, first finding that third angle. And the last case, if we are given all 3 sides, we would use this formula to find the area. All right? So this will be Monday's work. Then Tuesday's work is some practice problems out of the book. I think I am going to ask you guys to just upload your work straight to Schoology. Right? That's going to help me stay a little more organized. So if you could just submit your work, and you're still just taking pictures of it, so just take pictures and submit those directly to the assignment on Schoology. That'll help me out a lot. All right. And if you have any questions, please send me an email or a remind message. I'll be happy to help.